everyone, this is Megha and this is my first Capstone project. So my first project, I've taken up Airline Dataset, and the problem statement here, it outlines the challenges that the aviation industry is facing, such as the stricter environmental regulations, higher flight taxes, increased interest rates, rising fuel prices, and a tight labor market, which is leading to higher labor costs. And these challenges are impacting the company's profitability. So, the company does have certain mitigation strategies, which include increasing the occupancy rate to boost the average profit earned per seat, improving the pricing strategy to adapt to the market changes and customer preferences, and enhancing the overall customer experience from booking to boarding. However, based on the data set that we have here, which you would get to know in a minute, we would be focusing on if we can have any recommendations around increasing the occupancy rate based on the data explorations that we are going to perform. Okay, so I start off by loading the data, and this is what the data set looks like. Here we have information about the passenger, his first name, last name, gender, age, nationality, etc. We have information about the arrival and the departure airports and the date the flight was taken, and some information around the continent, country, and also the flight status, whether it was on time, etc. And okay, so I start off by performing some data cleaning operations here. Looking for zero values, dropping all the NA values, checking if there are any missing values in any of the columns, and also looking for any duplicate values that we may have. But the data set seemed to be very clean, so I'll be move further into data exploration. So I started off by performing some demand analysis where I'm trying to understand passenger demand by arrival airport and also the passenger demand by the departure airport. So on plotting this graph, I understand that there's a huge passenger demand um, from people from this airport JNB, which is in airport South Africa. And then I want to understand which country are maximum flights taking off from, and that's on plotting that we understand that United States has a lot of flights taking off from there. Okay, now moving further, I wanted to understand what is the demand of flights per month, and to do that, this is the graph that I created. Just to give an overview how I went about doing that is I use the departure date to get the month, extract the month from it, and then I just group by the month and the passenger ID. So this gives me a good picture of the passenger demands by month, and we can see that there's a huge drop in Feb, and also the peak is in August. So this gives us a little information about seasonality as well. Um, so this was an interesting graph, very informative. Okay, so then I move on to doing some segmentation analysis. I was very interested to know if, what age group of people fly the most. So I created a bins where I created four different categories that was under 18, 18 to 30, 30 to 50, and 50 plus. And we can see that people in 50 plus age segment, they take most of the flights. And that was an interesting exploration that I saw. And then further on, I also try to see what were the here these are not all the nationalities. I just picked up top 10 nationalities to see what nationality the passengers belong to. And so but the idea here is to understand different features that we have and see if there could be any sort of correlation, uh, that would help us solve our case. And okay, so I move further to so now what I'm trying to do here is to understand if the airline is able to meet the demand of the destination, or not, based on each month. So here I'm doing some sort of proportional allocation calculations. Now, this might not be the most accurate one, but given the data set, this is the best I could do. So, what I did was I calculated the total passengers for each destination, then calculated the passengers for all the destination, and then I calculated the proportional allocation of seats that you have for each destination, and then I grouped the data by destination month and counting the number of passengers. Then finally, I merged the demand data with the proportional allocations, and then I calculated the seats based on proportional allocations. And next step was to understand if the demand was met or not. So here I basically see if the actual passenger, how many passengers do we have, if it's less than or equal to allocated seats for that particular aircraft, and in that particular month. So here also I'm not checking for all the possible flights, but I'm looking at those destinations which have the most demand each month, and I wanted to see if the airline is able to meet that demand. And here is my final output table where I was. This is arrival airport where we're getting the incoming demand from, and if the demand was met. So clearly the airline is able to meet the demands from them, from those airports which have the maximum demand each month. So which is a good thing. And so I've moved further to understand what was the segregation of the different flight statuses. And so yeah, let's dive into that. So I started off by looking at top 10 countries which have the most delayed and cancelled flights. And it was United States, which would naturally be true because we did have a lot of flights from the United States in the graph we saw above. So we have the most delayed and cancelled flights from the United States. uh, so now I went on understanding what is the percentage of these flights that are being cancelled and delayed. um, so before that, I also, just to get a better visual of it, I plotted it out to see the top 10 countries with the most demand for flights, and which was United States as well, which was United States, and we've seen this before. So now, since we understood that United States is the one with most cancelled and delayed flights, but as I said, it also has a lot of flights too. So it was necessary for me to get an overall picture of what are the total number of flights and what percentage of those flights are getting delayed and cancelled. So this is what I do here. I find out the total number of flights here. So you have 97,746 flights, and out of which 32,528 flights are delayed. So that means almost 33% of the flights are getting delayed, and 33% of the flights are also getting cancelled. And this seems like and a thing that the airline should be looking into, because if if there's so many, almost one third of the flights are getting cancelled or delayed, so that means they need to work towards you know um, understanding why this is happening, and there should be a priority, and probably optimizing flight schedule could be one of the solutions to this, or enhancing maintenance procedures why this is happening. So this is a recommendation that I would give the airlines to look into. And here, this was just to get a better visual of what was the, you know, how the delayed and cancelled flight percentages look like in the US. And I also went further to understand which were the top 10 destinations in the US with the most cancelled flights. However, the overall picture gave me the better understanding of what the issue is here and how we can, what's the suggestion that I would give. So based on the data analysis, I feel like reducing the delayed and cancelled flight should be a priority, because approximately one third of the flights are experiencing these delays or cancellations. So focusing on reducing this, disruption should be a priority. And the airline can implement measures to improve the operational efficiency, such as optimizing the flight scheduling, enhancing maintenance procedure, and addressing any staffing issues that they might have to minimize these delays and cancellations. And because it's just, I feel like it's just taking up the airline's resources, which could be put into better use somewhere else. So that's the end of my project. Thank you very much.